going to continue our exploration of objects and classes in Python, specifically in terms of how they relate to inheritance, magic methods, and private or pseudo-private attributes and methods. So first off, I want to set out some of what we hope to accomplish, and I'm going to try to break this down into declarative knowledge, things that you know and you can state, and procedural knowledge, which are things you can do. So I hope that by covering this, we're going to understand how Python uses magic methods to define common tasks across objects. By that, I mean, what does it mean to print an object? What does it mean to compare an object? What does it mean to add an object as examples? And then procedural knowledge is understand how we define meaningful magic methods for objects. Okay, so let's talk about special or magic methods. Magic methods might be a slang term that I've picked up over the years. So a class can implement certain operations that are invoked by special syntax, such as arithmetic operations or subscripting and slicing, by defining methods with special names. This is Python's approach to operator overloading, allowing classes to define their own behavior with respect to language operators. So that's from the Python language reference. And this is essentially how polymorphism is achieved in Python. Remember, it's multiple shapes. So you can have different objects that behave similarly. Okay, there are a lot of special methods, some that are common to all objects, some that are common to a certain class of objects, like iterable objects, like lists or strings. But we've already become familiar with at least one special object, and that is the init constructor. So special methods are all defined by a double underscore, a method name, and then a double underscore. So just like there is this init method, there are string methods, also Unicode, and we'll go over that. And there are comparison operators. For in this example, it's the less than operator. And there's equivalent things for less than or equal to, not equal to, greater than, equal to, etc. So the syntax is, again, a double underscore, the method name, double underscore. Okay, learning how, gotta get rid of my typo. In learning how to write programs to solve your problems, you always need to keep in mind your process of abstraction. So this is relevant for defining the magic methods. What do I want to depict or compare, etc. So let's go over some examples of this. So, okay, designing a constructor. The key question when I'm designing a constructor is, what do I want to have as a common attribute for all these methods? So when I create a drug or a prescription, depending on what perspective you're working on, what do I want every drug or prescription to have? For example, does each drug need a unique identifier? Then do I need to keep track of all the unique identifiers that have... Oops, where's my... Probably not an efficient use of time doing my typo corrections. Okay, do I need to keep track of all the unique identifiers that have already been assigned? If I need to do that, then I need to do that at a class level. When I create a protein, what do I want every protein to have? When I create a person, what do I want every person to have? So these are the kind of abstraction questions that are relevant to the init method. Okay, when I'm talking about the string or the representation or the Unicode methods, these are special methods that are designed how to show an object in different settings. For example, the string method is invoked when a print statement or print function is called. Similarly for Unicode, if it's a Unicode object. Whereas a representation has a more, I don't quite know how to define it, like in the IPython notebook, when the cell evaluates a variable without a print statement, it's calling this represent special method. So you may think this is obvious. Deciding how to show an integer might be a relatively simple question, but think about a floating point number. The float might consist of an infinite decimal expansion like pi, or a repeating decimal expansion like 1/3, or a finite decimal expansion like 5/4. How do I choose how many decimal points to show? That's a question that has to be addressed, because that's the kind of thing that the string is going to take this decimal point representation, which it's a double C, so we have like 64 bits of information, and represent that in a much more compact form. In more complex objects than numbers, the choice of how to display an object can be, well, more complicated. Am I likely to have a lot of the objects in a collection where I want to be able to appreciate the objects together? If yes, then perhaps I need to create a very simple show of the object. If I'm likely to be evaluating the objects in isolation, can I provide a more detailed view? Are there going to be differences in when I'm going to be using a representation or a string that can account for that difference? Okay, if we're thinking about comparisons, how would you compare persons? We could compare people by age. And I'm implementing a class of a person where I'm going to do that. So I have my constructor, and I'm considering that everyone needs a name, a sex, and an age. And then I got these methods for this. And now I'm defining these magic comparison methods. So in this case, less than. So the comparison operators take two arguments, self, the current object, P, and then P in this case is another person object. And so I'm simply taking self.age and asking if it's less than P.age. And similarly for less than or equal to, I'm taking self.age and less than or equal to P.age, and so forth. Well, having defined that class, we can go through and we can create particular instances of those. So here I've got my list of different rock stars. So we got Mick Jagger, Pete Townsend, this is David Bowie, Exene Cervenka, I think Susie Sue from Susie and the Banshees. So I'm creating each of them, and I'm doing comparisons. So in this case I'm saying, is Mick Jagger less than Pete Townsend? Well, Mick Jagger, when I made this last year, was 70. Pete Townsend was 68, so that comparison is false. If I ask if he's less than or equal to Pete Townsend, that's also false. If I ask if it's greater than Pete Townsend, well, then that comes out true, and so on. So for this class, I've defined a comparison operators based on the age attribute. What if we wanted to compare by name instead of age? Well, okay, I can create a new class, define all that stuff, and now I'm creating these comparison operators where I'm concatenating the last name, first name, middle name, and then doing the same comparisons. And if we recall from our discussion from strings, this will take the ordinal position of the ASCII characters and do the comparisons. And now we instantiate these people again. So we got Mick Jagger and Pete Townsend. So M comes before, M is less than P in the ASCII encoding. And so when I ask, is Mick Jagger 2 less than Pete Townsend 2, that comes out as true. Similarly for all these other comparisons. So I created an entirely new class, person 2. How could I have achieved this with less work? I mean, if you look at it, I've already defined all these common things: the constructor, the get full name method, the get characteristics, that don't have anything different between person 2 and person 1. So I could have achieved this with much less work by defining an inherited class that inherits from person, and then simply defining these new comparison operators, which will override the the methods with the same names that were defined in the parent class. So here I'm doing this. I'm going to take a person 2b. It's going to inherit from person. So I define a constructor. I invoke the parent constructor using the super command. And then I just write my new comparison operator, special methods. And these will now hide the parent less than, equal to, and greater than, etc., and use these newly defined comparisons based on the names. Okay, so just to emphasize a key conceptual knowledge point is we can refine behavior by inheriting from a class and overriding particular methods with newly defined methods with the same name. Okay, so here I'm instantiating my person 2b's, and they are now using the comparison operators that are based on the name, not by age. Okay, these special methods are invoked in a variety of circumstances. For example, sorting. If I have a list of these rock stars and I sort them, it's going to be using the comparison operators. So in this case, I'm taking my original rock stars with the person class. So here the comparison operators are defined by age, and now I'm making another list where they are sorted by the comparison operators are based on name. And I'm printing these out, and so here's my original rock star list, and then I'm printing my sorted list, and you can see that these lists are not the same. So here in the first one I'm at 10662.025, and here I'm at 10662.0310. And similarly for the Rockstar 2 sorting, the lists are different, but it's not obvious how. That's because when we are printing the list, the elements in the list are being printed with the representation method. And this is a representation method that is inherited from the base class object, which is basically just telling what kind of class it is and what's its memory location. So we can make our application there look better by changing, by providing string and representation methods for our objects that would override the inherited string and representation methods inherited from object. Okay, again, emphasize a key conceptual point. Every object has these methods already defined, at least for the case of the representation and the string. They're inherited from object, which is the base class for all objects. And we can see here that if I explore like the double underscore methods that are associated with MJ, that I have all of these methods, including the comparisons and the string method. Okay, and then just to emphasize a key conceptual point again, that some parent objects have different magic methods defined. So for sequences have methods that let you get the next element in the sequence, etc. That something like a number does not. Or so just a base object is not going to have that. So if we look at, there's a module ABC, which stands for abstract base classes, and we can explore different attributes that are common to the, so this is the base class for a dictionary type. So you see it has a call method, a comparison method, a delete item method, comparison methods, hash methods. Okay, and if we did a by comparison, let's see, abstract types, do we have a list type? Let's do this. Let's do a, let's see, does it have a string type? So I don't quite know what I'm trying to explore here, but there are a variety of these methods that are defined. And if we take our person class, let's see, if we take our person, oops. Okay, they do have a hash method. Do they have a next? They do not have a next method or an iter. So there is going to be a different set of inherited methods depending on our inheritance path. Okay, so representation and string are called in different settings, so we can customize the look for different circumstances. So here I'm taking a person, and again I'm going to be smart and I'm going to inherit from the person class. And so I call the constructor, use super to invoke the constructor for the parent person class. And now I'm going to define a representation, and this is going to create a string where I'm just going to put in the name and age, and then I'm going to have them comma separated and delimited by vertical bars. Whereas for the string method, I'm going to get you see I got a line break, so I'm going to have a string that's going to print over multiple lines the first, middle, last name, sex, and age of the person. Then I've defined a Unicode, which is just going to take that string and convert it to Unicode. So here we create some new rock stars with a new inherited class. And now I put them in a list. And you see when I print the rockstar list, it's using the representation method. But if I print out a particular rockstar, in this case, Susie Sue, it's a string that's printed over the multiple lines. Okay, so that's our initial exploration into magic methods. Okay, it kind of came up in class, the issue of private attributes, and we talked about the principle of encapsulating, that you want the user to access attributes via class methods rather than accessing them directly. And you can try to force this by making attributes private. So private attributes are created by prepending 2 underscores to the name. For example, if I had a variable weight and I preceded by 2 double underscores, and no more, then that variable will be viewed as a private variable. So here I'm just creating a simple class A, which has an attribute num with a single underscore, and now class B, which has an attribute, it inherits from A, so it takes a number and now it has a name. And you see with the name, I'm using the double underscore, and I'm providing a getName method that will return that variable to the user. So I can create instances of each of them, and I can print a._num. So since this is a single underscore, it is not a private attribute, and so it can be directly accessed by the user. Okay, now, but if I now try to access, I can access B num because it inherits this from A, and I get 1, it's accessible. But when I try to access double underscore name, which I did indeed define in my class definition, then I'm told by Python that B has no attribute name. So what's going on here? I can use getName, and it nicely returns Brian, and if I come back up here to my definitions, I see that getName is simply returning self double underscore name. So it seems like that exists. So what's actually happening? Well, name isn't actually private, but what Python has done is when I've declared a name with a double underscore, it has done some obscuring to try to hide it from the naive user by doing what's called name mangling to obscure the name. So it's taking the class name, it's taking a single underscore, the class name, and then it's concatenating that with the attribute name. So if I access it this way, single underscore b, which is my class name, double underscore name, which is my attribute name, I can access it. So it hasn't really protected it in the private sense of another language like Java or C++, but it's at least made it known to the user that I don't really want you accessing it. I know that if you know enough, you can get at this, but I really wish that you wouldn't. Okay, so let's define an example of this and show why it might be useful. So I'm defining a patient class which inherits from person, and I'm adding attributes primary care provider, a chief complaint, and a medical record number. And I'm making a medical record number a private attribute by using a double underscore. I have a representation and string methods, and I have get and set methods to return the value and to set the value. And the set method is kind of an illustration of one of the reasons you might want to make the user access an attribute through methods rather than directly. In this case, I'm going to do a validation. So I'm getting a medical record value in, and I'm going to check and make sure it's alphanumeric. I'm going to assume that my medical record number is an alphanumeric string, and I'm going to first try to see if it's alphanumeric. So this is assuming it's a string. And if it is not alphanumeric, has punctuations or spaces in it, then I'm going to print a message that it's not a valid medical record number. I'm not going to change the attribute of the object, and I'm going to return false, which is just basically to tell the program that the procedure failed. If I am able to check that it's an alphanumeric string, and it is in fact an alphanumeric string, then I will change the private attribute double underscore mrn and return true to tell the calling program that this was a success. I have this all wrapped in a try except because is alphanumeric is a method of a string. So if I pass in something that's not a string, then I will get an attribute error, which I'll give the same message that it's not a valid medical record number and return false. So with this class, I can define a patient. I can try to set the medical record number with a list, which it tells me it's not a valid medical record number. When I try to get it, I can get the medical record number because it was instantiated with a 0 from the constructor. Then I'm going to create a new variable, mrn. This is indeed an alphanumeric string, which I test right here before I call it that it's true. So I get the medical record number, pass it this, and now when I get the medical record number, I have now changed that value. It's now the value that was defined in passing that string, and just showing that it's still hidden. I can't access it directly. All right, so that's our next exploration of classes and more details about them. There's some additional reading here, links for listing of many special methods that are available in classes, and another thing about how to emulate numeric types.